Hey class, so this is an optimization problem. Has to do with a curve y equals x. So y equals x, that's really relationship between y and x. And so if you have any point, say xy on the curve, y equals square root of x, you are to go ahead and find the nearest point to the point for 0. Okay, so if you really think about the distance L right there, we want that distance to be minimized, meaning the nearest distance, right? So the distance L is going to be square root of Pythagorean theorem, right? This would be x right here, and this would be y right here, right? So then you would say x minus 4 square plus y minus 0 square. Okay, so that's the distance. And y is equal to square root of x. So once you take that and substitute that in there, the distance L in terms of x is going to be square root of x minus 4 square plus square root of x squared, which is x. Okay, so that is what we need to minimize. Minimize. Can't spell minimize. Okay, so what do you do to minimize? Find a derivative, right? And so if we were to multiply this out, this is square root of x squared minus 8x plus 1x is minus 7x plus 16. Okay, so that is our function. The derivative is going to be 1 over 2 square root of x squared minus 7x plus 16 multiplied by the inside derivative, which is 2x minus 7. And I'm not sure why I wrote it all the way down there, because I could actually write it up here. 2x minus 7. Okay, so when is this? Where are the critical point, right? So critical point would be when the derivative is equal to 0 or when the derivative is undefined. So the derivative is undefined when the denominator is 0, and the derivative is 0 when the numerator is 0 in this case. So when is x squared minus 7x plus 16 equal to 0? Oh, can we factor that? 2, no, we cannot factor that. So x equals 7 plus or minus square root of 49 minus 4 times 1 times 16, all divided by 2 times 1. 4 times 16 is 64. You'll have a negative number right there. So this is imaginary, so that's not going to happen. That's not going to give you a critical point. All right. Now, when is the derivative equal to 0? When 2x minus 7 is equal to 0. So x is 7 over 2. Okay, and then so we will check to see if it is your minimum, in fact, right? So pick a number to the left and pick a number to the right, or what you could have done is to also find a second derivative, and I don't want to go find a second derivative there. Let's just use the first derivative test. To the left of, this is 3.5, to the left of it, let's say take 3, 3 times 2 is 6 minus that is 7. So that is negative on the numerator. And on the denominator, we will have 3, that would be 9, 21, 16. 9 plus 16 is 25. 25 minus that is 4. That would be a positive number on the denominator. So this right here, the negative, and so it's decreasing. And then let's pick a number to the right, say 4. Okay, say 4. Then you will have 8. 8 minus 7 is 1. That's positive. And then on the denominator, we are looking at 16 plus 16 Well, you know what? Why doesn't that make sense? Because that cannot be 4. If x is 4, it would be right here at that point, and that's not fair. The closest point to the point itself is right there. Or this would be this guy right here, 4, 2, which we know is not the closest point, right? So the x value has a limit between 0 and 4. So you would have to pick a number that is, say, to the right of 3.5, say 3.7 times 2. That would be like 6.4. So the numerator minus 7 is going to be a negative on the numerator. And then, no, that is positive. 7.5. 7.4 minus 7 is positive. Been doing math for so long today that I actually am not having my mental math here. And the denominator here is going to be well, if I put that into my calculator and I calculate that, that is also a positive. So then the derivative here is positive. So we would have then a minimum because it's going decrease and then increase. So there's a minimum right here at 3.5. So that is our minimum x value. X is 3.5. If x is 3.5, then y is square root of 3.5, whatever that would be. And I think if we go and calculate using decimals, I would say, hey, that is what is square root of 3.5. Square root of 3.5 is 1.87. So our point is approximately 1.87. And there we go. That point right there, 3.5, comma 1.87 is the closest point on y equals square root of x to 4, 0. And that is it.